Maybe. Okay, so we're gonna go over the ideas in this workshop. The first question was giving you two differential equations and asking you to see if it's exact or not. So, exact or not. So the first one was 3yx squared 2y squared x dx, and it was 2x cubed 3y x squared plus 1 dy all equal 0. When they ask a question of whether it's exact or not, similar to Cal 3, whatever multiplied by dx you call m, and whatever multiplied by dy you call n. So your m is 2yx squared 2y squared x. And since this is m and it's in dx, you find its derivative with respect to y. So a constant y would be the constant, and here you bring the 2 down, becomes 4yx. This one is 3, sorry. So you find the derivative, and constant y would be the constant, and this would become like this. Good? You also have n as being 2x cubed plus 3y squared x plus 1. And since this one is in dy, we find its derivative with respect to x. 3 down. A constant in front of the x would be the constant, and 1 is gone. Now, this is the, so we do the derivative with respect to x. Sorry, I keep writing them wrong, so here. And the derivative with respect to x, 2 times this, 6yx, and the derivative of 1, nothing. Now, are these two equal? You'll see that my does not equal nx, so they're not exact. Good? We'll do question 1b. Question 1b, it was giving you 2xy y squared ex dx and x squared plus 2y ex dy equals 0. Again, whatever multiplied by dx, that's your m. And whatever multiplied by dy, that's your n. Since this one is dx, we find the derivative with respect to y. A constant in front of y would be the constant. Here would be 2y ex. N would be x squared 2y ex. Since this is dy, we find the derivative nx. Derivative of this is 2x derivative of e times a constant would be just the e times a constant. Now if you check, you'll see that my in fact equals nx, so this one is exact. I also have an old question, Diego, and there was an idea in this question, so I'd like to go over it. It was, again, exact or not. So this one is extra. It was x minus y cubed plus y squared sine x equals 3xy squared plus 2y cosine x dy dx. Now, in the previous two examples, like in example 1a, you had something like this. Dx, and then it was 2x cubed 3yx squared plus 1 dy equals 0. So you gotta have something dx plus or minus something dy and 0 on the other side. Here, this question is given so that you have something on the left-hand side and something on the right-hand side, so it doesn't work. First of all, you need to have everything here and nothing on the right-hand side, so we bring everything over. So x, y cubed, y squared sine x. I'm going to bring the bracket over, it becomes minus the bracket 3x y squared 2y cosine x dy over dx equals 0. So now I have the 0 on the left. Here, there's still another problem. I have a dy over dx here, and I have to have something dx, something dy. So what I'm going to do is, I'm going to multiply both sides of the equation by dx. So this by dx would be xy cubed sine x times dx. This times dx would be 3xy squared 2y cosine x times dx cancels, you only have dy, and dx times 0 is 0. So now we have it in the right form. Something dx, something dy. This now is your m, and this here is your n. So your m is x minus y cubed y squared sine x. And since this one is dx, I'm going to find the derivative with respect to y. One doesn't have a derivative. This with respect to y, 3y squared. This with respect to y would be 2y sine x. N would be minus this, so it would be minus 3xy squared minus 2y cosine x. And since this one is y, I'm going to find the derivative x. A constant in front of x would be just a constant. The derivative of this with respect to x, derivative of cosine is minus sign, and a minus becomes positive 2y sine x. Now if you check, you'll see that the two are equal. It is exact. So if he gives you the question in this form, where something dx, something dy, and asks for exact, do it right away. If it's not, and that's a possibility that it could not be given in this form, so you need just to manipulate this to make it look like this. So you bring everything over, and you get rid of the dx by multiplying. Good? I'm going to come back to this question later. So remember the m and the n. We're going to come back to this later. Now I'm going to move to question 2. Question 2a is determine what type of differential equation this is and solve using the corresponding method. So you have x dy over dx, you have 3y, and you have sine x over x minus x squared. The idea of what type it is, this one we call linear. Why is it linear? Now look at the x and the y. Y, for example, is to the power 1. X is to the power 1, negative 1, x squared. So x we don't care about, but y is to the power 1. So when one of them is only to the power of 1, then it's linear. So once you determine that it's linear, you have to have dy over dx by itself. So I'm going to divide by x. I'm going to divide everything by x. So this one divided by x, gets you dy over dx. This one divided by x gives you 3 over xy. You divide by x, you add another x here, becomes x squared. You divide this by x, it gives you x. Now, there is something called, once you have it in this form, there is something called the integration factor. So the integration factor, the IF. And the integration factor is E integral of px, where px is whatever you have in front of the y. So whatever you have in front of the y after you isolate the dy over dx, so 3 over x, that's your px. Now you integrate. You know, the 3 over x would be 3 ln x. That's the integral of 3 over x. You can, one of the features of ln, you can bring this up and write it as ln x cubed. So again, bring 3 and make it up as an exponent. Now e and to the power ln, they cancel each other, so your integration factor is x cubed. So e to the ln, they cancel each other, so your integration factor is x cubed. Once you have the integration factor, you're going to multiply both sides of the differential equation, this one. You're going to multiply both sides by the integration factor. So I'm gonna take the x cubed and multiply everything by x cubed. You multiply this by x cubed, you get to x cubed dy over dx. You multiply this by x cubed. You cancel one x with the bottom x, so you have 3x squared y. You multiply this by x cubed, you cancel x cubed, 2 from the x cubed with 2 from here, you have x sine x left. You multiply this by x cubed, gives you x to the power 4. Good? Now this is the tricky part. This one here is the derivative. You take the x part and the y. So this whole thing is the derivative of x cubed, whatever you have with the dy over dx, and the y part. You can actually check. Let's find the derivative of this quickly. I'll use a different marker. Implicit differentiation, product rule, derivative of the first one times the second function. Derivative of the second function, derivative of y is y prime times the first function. And you can write this as, instead of y prime times x cubed times y prime, which is dy over dx, and you'll see that's the same thing. So, once you multiply by the integration factor, and you have it this way, whatever you have with the dy over dx, you put first with the y part, and you say this is the derivative of this. This whole thing is the derivative of x cubed y. On the other side, you have x sine x to the power 4. Now, once you get to this step, you can integrate both sides of the equation. Integral of a derivative, they cancel each other. So the integral and the derivative, they cancel each other. Here, I need to integrate this and integrate this. So I'm going to go to the side. See, I put a dx. How can we integrate this? Well, if you remember, this is one of the famous biparts equations. So you let u be x, then du would be dx. And dv would be sine x dx. Then v would be minus cosine. Then I equals uv minus v du. So I equals u times v, this times this, so minus x cosine x, integration of minus cosine x dx. So minus x cosine x, minus minus is plus, integration of cosine is sine. So you go back here, integration of the first one is negative x cosine x plus sine x, and the integral of this 5 over 5, and as I told you last time, plus a constant, and it's always with the right hand side. You could leave this like this, or you can say I'm gonna take this down, so I'm gonna divide here by x cubed. That would cancel x, leaving you x squared here. Divide this by x cubed. When you divide this by x cubed, you have 2 over 5. and you divide c, so it becomes c over x cubed. This here is the answer for the differential equation. Okay. Now, the other question, 2b, was similar to one of the questions you had at the beginning, I think 1b. It's this one here. And if you remember, question 1a, we actually proved that this one here is exact. So once you prove that it's exact, knowing that my equals mx, so it's the same question, your m is 2xy y squared ex, and your n is x squared 2y ex. The question 2b now is to solve. So in 1a was to determine whether it's exact or not. So now once you know it's exact, how could you solve this? The way we solve it is you integrate the m dx now, plus you integrate the n dy, and you make it equal a constant. But here, no x terms. Meaning, you put the m entirely, so it becomes 2xy y squared ex dx. Here when you go to n, first term, there is x. No x terms. You cannot have x terms. So x squared, so you cancel this. This one has x, you cancel. So in this case, you're integrating nothing, dy. There are no isolate y or y terms by themselves. So you integrate this with respect to x. So this becomes x squared y. This stays like it is. Integration of 0 would be a number, so we just say k, so to distinguish this. C. You can bring the c over. K minus c equals 0. And you can say k is a constant, c is a constant, I can call it something else. I called it a, so we can say that the final answer is x squared y squared ex plus a equals 0. Good? Now, I'm going to do, remember when I gave you an exact question? The question where sine x and cosine, when it wasn't in this form, and we had to bring it over, multiply by dx, and I told you we're going to come back to it. And the question that I showed you earlier, and that I told you that we're going to come back to it later. It's good if I can find it. Yeah. we came to the point that it was looking like this. It was x minus y cubed plus y squared sine x. All of this with dx minus 3xy squared 2y cosine dy equals 0. And this is after we played with this and we brought it over. Now, here we know it's exact. We proved earlier in this video that it's exact. So your m is x minus y cubed y squared sine x, and your n is the minus xy squared 2y cosine x. This is your n. Now, you're going to integrate both sides of the equation and see what you get. So you're going to integrate the m first, which is, again, I'm going to apply this concept here, which is m dx n dy equals c. You're integrating this, so it'd be x y cubed y squared sine x. And this one is integrated dx. You integrate the n, but like I told you, no x terms. This one has an x term, you cancel. This one has an x term, you cancel. So again, you're integrating 0. It's not necessarily going to be 0, happens to be 0 in both examples, but sometimes you could have something. So the integration of this with respect to x is x squared over 2. This one with respect to x would be y cubed x. This one with respect to x would be minus y squared cosine x. The integration of 0 is a constant equals c. You can bring the c over. And when you bring it over, it becomes k minus c0, and k minus c0 you can call a, and have it in where a is a constant. Good? Also, I'm going to do another first order. Now remember the question 2a. Remember this question? And we say it's linear because y is to the power of 1. We had to isolate the dy over dx. So first step, I divided by x, so I'm going to write it quickly. Then I told you, whatever you have in front of the y, that would be your integration factor, px. And the integration factor would be e to the integral of px dx. So it would be e to the 3 over x dx. So we figured this is 3 ln x. We figured that we can bring it up, and that's x cubed. This is your integration factor. So I multiplied everything by the integration factor. And that gave me x sine x here and x4. And I told you, whatever you get here after multiplying by the integration factor, you can say this is the derivative of whatever you have with the dy over dx and the y. Now you integrate both sides, integral derivative cancels out. Integral of this we done by parts, and we figured that it's x, negative x cosine x plus sine x, and this was x5 over 5 plus constant, and then I divided everything by x cubed. So I'll give you another example. Also, Diego used before, x dy over dx, 2y, 1 over x cubed. First, is this linear? Well, x to the power 1, but here is to the power of negative 3 if you bring it up. But y to the power 1, so that tells you it's linear. First order. So, first of all, like we did here, we need to isolate this. So I'm going to divide this whole thing by x. That would give me dy over dx here, 2 over x, y, and you divide this by x, gives you 1 over x4. Step 2, you need your integration factor. And it's e to the integral of px dx. And I told you, px would be whatever in front of the y. And as you know, the integral of 2 over x is 2 ln x, so this is e 2 ln x. You can bring the 2 up and say this is like ln x squared. E and ln, they cancel each other. This is your x squared. This here is your integration factor. After we got the integration factor, we took it and we multiplied this, the one where we start the question. So not the beginning, after we isolate the dy over dx. After we isolate the dy over dx and finding the x squared, we take this times the whole thing. So this times the whole thing here. It becomes x squared dy over dx. X squared here cancels, so you have 2xy. And x squared times this cancels with 2 of them, so it becomes x over 2. Once you get to this step, you can say that this here is the derivative of whatever you have with the dy over dx and the y. You can check. If you find the derivative of this, do we get this product rule? Derivative of this, derivative of x squared is 2xy, and plus derivative of y, which is dy over dx times x squared. And 1 over x squared, we can write as x to the minus 2. So at this step, when you get to this point, you can integrate both sides of the equation. Integral of derivative, they cancel the derivative. Here you add 1 to the exponent, divide by the exponent. So this is plus c, of course. The c is always on the other side. You can divide by x squared. I mean, this one here is like minus 1 over x. So you divide by x squared, you have negative 1 over x cubed, c over x squared. This here is the answer for the question. Now, I know that eventually it might get a little bit more complicated, but for now, it's not bad, and I think you can handle it. So maybe every time I'll do the workshop, I'll do the questions, and I might actually add 2 or 3 questions just so that you understand the concept very well. Again, if you have any question, please watch this video. It's not a long video, so watch it completely. And if you have any questions, let me know. Bye.